This is just a quick reminder that you should feel free to pause the video if you ever feel you want more time to think and write.
Hey everybody, welcome to section 5.3, day 1, logarithmic functions. Logs, yes. Logs are incredibly important, and they're also can be incredibly confusing too, but we're going to take it slow, we're going to take it step by step, so check this out. We have been working on exponential functions for the past couple days, and here's an exponential function. It's like 3 squared equals 9. Great. We all know that 3 times 3 is 9, but if you look at this equation, we're going to identify some parts to it. 3 is what we're going to call the base, 2 is going to be what we call the exponent, and 9 is going to be what we call the power. Well, if you switch those around, you can interchangeably say that in a logarithmic equation, 3 is going to be here, the base, just like it was here. 9 is going to be the power, just like it was here. And 2 is going to be the exponent. What we're basically saying is that you take as an input the power to the log3 function. The output is going to be an exponent. And so we're going to spend a lot of time just making sure that we know how to convert back and forth between these two. So much so that there's going to be a little, let me show you what it looks like to draw this out. What you do if you want to convert between the log back to the exponential is you switch the power and the exponent. And here, so this is when you switch the power and the exponent, you're going to go, the 2 is going to go back with the 3, and then the 9 is going to be all by itself. Here, if you want to change this to the log, you see that you can switch the exponent and the power. The 2 is going to become all by itself, and the 9 is going to be over here with the 3. If you want to switch these two, go back and forth between the exponential version of this equation and the logarithmic version of this equation, then a really great thing to do is just make sure you switch the base and the don't switch the base, switch the exponent and the power. The exponent and the power. The exponent and the power. Make sure you switch those two. Alright, logarithms answer the question, what is the exponent? You can see here, if you're given log 3 of 9, and the textbook asks you to compute what is the log 3 of 9, it's basically saying when the base is 3 and the power is 9, what is the exponent? And so what is the exponent? It's 2. Logarithms answer the question, what is the exponent? And in exponential notation, so we're going to practice going back and forth between them. Here's exponential notation. We've already seen this before. It's the above example. But what would this look like? 10 to the third does equal 1,000. If you were to translate this into log notation, you would say that the base is 10, the exponent is 3, and the power is 1,000. So let's say you had to somehow cover this up. Log base 10 of 1,000. What is the exponent when the base is 10 and the power is 1,000? What exponent would you need in order to produce 1,000? You would need 3. Now, I will say that log base 10s are actually the most common bases out. Base 10 is the most common base out there. So common that it's assumed that if you don't see, if you have an unwritten, if the base is not there, you're looking at it and you don't see it, then you can just assume that it's base 10. That's how common base 10 logarithms are. All right, again, 2 to the negative 4 does equal 1/16. The base is 2, the exponent is negative 4, and the power is 1/16. If you're going to translate that into a logarithmic equation, you can say here, the base is 2, the power is 1/16, and the exponent is negative 4. You can get that, you can produce that by switching the exponent and the power. So you can see here they got switched, and we have log 2 of 1/16. What exponent would be necessary to produce a power of 1/16? You would need an exponent of negative 4 when the base is 2. So going back in the other direction, if you had a base of 10 and a power of 10 10,000, then what exponent would you need in order to produce a power of 10,000? Well, what exponent? It could also look like this. Base 10 to the x is equal to 10,000. Remember, we're just switching the exponent and the power, and then that's how you write it in exponential. The big goal for today is just make sure you can go back and forth between these equations. Not necessarily solving them, but just translating them back and forth between the two different versions. Here, you switch this, and all of a sudden you get 10 to the x is equal to 0.01. What exponent is necessary? Well, you might guess that the exponent of negative 2 would be needed to produce a 0.01 as a power. And so the log base 10 of 0.01 would be equal to 2. Here the base is 5, the power is 125, you switch the power and the exponent. Switching the power and the exponent, you get 5 to the x equals 125. Log base 9 of 3 is equal to x. That would change it to 9 to the x equals 3. 6, if the power is 1 and the base is 6, then what is the exponent? That's what the equation looks like. And lastly, log base 8 of 8 is equal to x. So you can translate that into 8 to the x is equal to 8. And you might notice that if you read it in these forms are a lot easier to figure out what the answer would be. For example, 8 to the x would be just 1. X would have to equal 1 in order to make this equation true. So what is log base 8 of 8? That's equal to 1. And like I said before, if there's no base written, just assume it's base 10. It's the most common logarithm out there. Okay, so convert each to a logarithmic equation. Going back in the other direction, you can still switch the power and the exponent, and you can see x is equal to log base 2 of 16. What is the exponent when the base of 2 and 16? It's x. Here, switching the exponent and the power, you get log of 0.001 is equal to negative 3. Again, the base of 10 is so common that I don't even need to write it. You can just say log 0.001. You don't have to say log base 10. You can if you want to, but it's not necessary. Here, I don't know what e is, but if I switch 10 and 70, you get log base e of 70 equals t. We'll figure that out later. Here's a variable, 625 is equal to 5 to the b. And so we're going to switch these around. The exponent goes over here, the power goes over here. You get log base 5 of 625 equals b. Here's one that has absolutely no numbers at all. That's okay. You can switch the exponent and the power, and then you get b is equal to log base a of p. Log of 3 is the base, y is the exponent, and 5x is the power. So you switch them around, the exponent goes by itself, log base 3 of 5x. 5x is the power. If you eat your calcium, then you might be able to do part A all by yourself. You might be able to see that the calcium helps you switch the exponent and the power. You've got 2 to the 5th is equal to 32. Calcium is your audio check answer for today. Switch these, you get the power and the exponents get switched, and you can see it's base a to the 8 is equal to q. X equals log base t to the m. So switching things around, this is the power, this is the exponent, and then t is the base. So it's t to the x is equal to m. Log, there's an unwritten 10 right here, so you can say it's base 10, exponent is 2, 10 squared is equal to x. I want you to do letter F. Switch these and tell me what equation you get. And then log base e would be e squared equals a. Anyway, that's the assignment. Those are the notes. I want you to start assignment 5C1, copy the problem list, do the first problem, and I'll see you in class.